In this demo, I will talk about compound surfaces. I gave you this handout, and in this handout it covers some of the basic compound surfaces methods. And the first one is the one I will be talking about. So if we look at the second one, let's talk about what's going on here. We're looking at this convex major surface, and the transitional surface is very simple. But so the thing to note about this specific example is that this is not a revolved surface. You have a cylinder, which technically could be a revolved surface, but then the concave, or convex in this case, the convex surface it's not a revolve, it's an actual plane that is achieved by moving the control points of that plane. So in a way, this is a free-form modeling technique, and then the larger plane intersects this cylinder, and we create a very simple transitional surface, in this case a fillet surface. So if you use this same method and you use a revolve for the convex surface, then you're technically not using compound surfaces. So please pay attention to that. Now the third example was this example of using a bunch of revolves. So at the top of the example on the right, this is a plane, so this is not just a 360 revolve, and still it's not complex enough because it's a bunch of extrusions in a way. Everything is either an extrusion or some kind of revolved shape, and the transitional surfaces are simple fillets. So this is just not good enough. It's just too simple. I would expect you to be able to do this type of form around week 3 or at least week 4. And then on the left, I'm showing you something a little different, where this could technically be a revolve and then scaled in one dimension. And then there is this very complex transitional surface, which is a type of blend surface. But the way it's controlled is by creating curves, looking at the curvature of these curves, and aligning the curve to match the edges of this cylinder, and just really controlling how the transition happens. So this is why it would be acceptable as a compound surface, because this is not a simple blend surface. This is broken up in quarters, and each of the sections is controlled by curves, and these curves are being closely looked at so that they have the right type of curvature depending on the design intent. So this would be acceptable. The previous one is acceptable as long as it's not a revolved surface, as long as it is a free-form surface. And the first example is what I really want to see in your model. So if you don't have a single compound surface that is built in this way, then your grade is not going to be as high. So this is, first of all, it's broken up in quarters. Now you don't have to do that, but this helps so that you can just build one quarter, right? And essentially what's happening here is you have a freeform plane. So this is a plane that is larger than the edges that you see here. So it's a plane that's been trimmed. If you look at it, it has 1, 2, 3, 4 edges and 5 edges. So a plane is usually 4 sides, not 5. So the 5th corner is where the corner happens, where this transitional surface happens, which means that when we trimmed this freeform surface, we created a curve, and we created this corner surface. So it takes a lot of work, right? You have to think about how this surface wraps around, how it is trimmed to achieve a clean edge, and then how the transition happens. And so that's what constitutes a full compound surface. Not only it's a nice freeform surface to begin with, it is trimmed, and on top of that, the transitional surface is also controlled. So it's all about control, right? We don't want a single transitional surface that wraps around the entire object, where the surface begins and ends at the same edge, because this is similar to a revolve, and it just lacks the amount of control that we look for at this level in the class. So at this time, I really want you to showcase your ability to really control a surface and the curvature of your overall object. And so there's two things I'm looking at. I'm looking at your major surfaces, the larger surfaces which are trimmed, and the transitional surface, which is where you would technically have a fillet, but instead of a fillet, here you have what we call a chord. So you're controlling your fillet by creating a curve and then creating something such as a sweep, maybe a sweep 2, so that you can create all of the four sides by creating curves, and really controlling how the curvature changes depending on your object and your design intent.